A man was pulled out of his 12th floor apartment by a tornado. Not out of a ground floor house, not off a roof, out of a 12th floor apartment, along with his furniture, a couch, cabinets, pieces of an interior room that should have been sealed behind concrete walls 60 meters above the street. All of it ripped outward and thrown into the air. This is what Typhoon Maysak did to central China. Not on the coast, not near the eye of the storm, hundreds of kilometers inland in Hubei province. In a region where most people were watching the typhoon track on their phones and thinking the worst had already passed. It had not. And what happened in Guangxi tells us something important about how typhoons actually kill people. And why the most dangerous part of a tropical system is almost never the part that appears on the map. Subscribe and turn on notifications now, because this storm sequence is not finished, and what comes next is going to be worse. Let us start with what actually happened. 2 tornadoes tore through eastern Hubei province over a period of several hours. This was not a brief spin-up that touched down for a few seconds and disappeared. These were sustained, violent rotating storms that moved through populated areas around Guangxi, Guangxi, and Jiangling. Leaving a path of destruction that emergency teams are still assessing. The numbers tell part of the story. At least 11 people were killed. Hundreds were injured. The final count is likely to be significantly higher as rescue teams reach damaged areas that were initially cut off. Nearly 5,000 homes were damaged. Dozens of buildings collapsed entirely. 1 person remains missing. But the numbers do not fully capture what happened, because these tornadoes did things that tornadoes in populated areas almost never do on camera. At a logistics warehouse complex near Guangxi, the storm hit with such concentrated force that steel structural beams were bent and snapped like matchsticks. Trucks, not cars, trucks, were not just overturned. Some were lifted off the ground and thrown approximately 30 meters. That is roughly 100 feet. Loaded commercial vehicles, airborne, traveling the length of a building before hitting the ground. At a residential high-rise, the force of the wind penetrating the building created a pressure differential so extreme that it functioned like depressurization in an aircraft cabin. When an airplane door fails at altitude, the pressure difference pulls everything near the opening outward with violent force. The same physics applied to a 12th floor apartment window when the tornado passed. The man inside was pulled out. His furniture went with him. These are not descriptions of a gust front or a severe thunderstorm. These are descriptions of a tornado operating at the upper end of its destructive capacity, concentrating winds that, in a typhoon spread across hundreds of kilometers, would be dangerous but survivable, into a corridor sometimes only a few hundred meters wide, where the wind speed increases to unsurvivable levels in seconds. Now here's the question that matters most. How did tornadoes form in central China, hundreds of kilometers from the coast, 2 days after the center of a tropical storm had already made landfall and begun weakening? The answer requires understanding something about typhoon structure that most people never learn, because the maps and forecasts that dominate public coverage of tropical cyclones focus almost exclusively on the eye and the eye wall, the most visually dramatic part of the storm. But a typhoon is not just its center. It is an enormous atmospheric engine that reshapes the entire weather pattern across a region the size of a continent. When Typhoon Maysak stalled over Guangxi and Guangdong and began pumping moisture-laden air from the South China Sea inland. It did not stop at the coast. That warm, saturated air traveled hundreds of kilometers into the Chinese interior, feeding thunderstorm development far outside the main circulation. And as that moisture interacted with the broader atmospheric wind pattern, with winds at different altitudes moving at different speeds and in different directions, the conditions for tornado formation quietly assembled. Here is the specific mechanism. Near the ground, warm, wet air was being pulled inward toward the low-pressure center of the typhoon system. Higher in the atmosphere, stronger winds were moving in a different direction. This difference in wind speed and direction with altitude, what meteorologists call vertical wind shear, creates an invisible horizontal rotation in the atmosphere. It is not visible from the ground. It looks like nothing, but it is there, a slowly rotating tube of air lying on its side, spreading across the region. When a thunderstorm updraft develops in these conditions, it intersects with that horizontal rotation, tilts it upright, stretches it, and tightens it. The result is a rotating updraft, a mesocyclone, and a mesocyclone that reaches the ground becomes a tornado. This is how a typhoon that made landfall on the coast of Guangxi produced tornadoes in Hubei province. The storm did not need to be overhead. It only needed to have restructured the atmospheric environment enough that when thunderstorms developed in the feeder bands ahead of the system, the ingredients for rotation were already in place. This pattern has a specific implication that emergency managers and the public consistently underestimate. Tornado warnings issued in the context of a typhoon approach are frequently dismissed or mentally categorized as secondary threats by populations who are focused on the main storm. In Hubei province, the typhoon track showed the center moving through Guangxi and southern China. Residents in Huanggang looking at that track would have reasonably concluded that the worst impacts were happening elsewhere. They would have been watching flood alerts, not tornado warnings. And that is exactly the gap where people die. China does experience tornadoes, but a destructive inland outbreak of this magnitude in Hubei is rare. Local reports describe it as the most significant tornado event in the province since 2021. A population that has not seen a tornado in 4 years does not respond to a tornado warning with the same instinctive urgency that it responds to a typhoon warning or a flood alert. The threat feels abstract. It feels like something that happens elsewhere. And then it arrives at 180 kilometers per hour through a 12th floor window. The damage pattern on the ground confirms the tornado diagnosis clearly. Typhoon damage is distributed broadly across a wide area. The winds are dangerous everywhere within a large radius. But the destruction in Huanggang followed narrow, concentrated corridors, where the level of damage went from severe to catastrophic within the width of a street. Buildings on one side of a road nearly intact. Buildings on the other side reduced to structural frames. That is the signature of tornado track. Extreme, localized, following a path that the storm carved through the landscape before lifting and touching down again somewhere else. The steel warehouse beams bent into curves, the trucks thrown 100 feet, the 12th floor apartment emptied into the sky. These are not wind damage signatures. These are tornado damage signatures, and they place this event well into the range of what meteorologists would classify as a significant tornado outbreak by any international standard. There is a broader pattern here that deserves attention. Typhoon-spawned tornadoes are one of the most consistently underreported and underappreciated hazards in tropical meteorology. In the United States, research on Atlantic hurricanes has documented that landfalling tropical cyclones produce tornadoes with surprising regularity. In some cases, dozens of tornadoes in a single event spread across states that are hundreds of miles from the storm's center. Hurricane Yvonne in 2004 produced 117 confirmed tornadoes across the southeastern United States as it moved inland. Hurricane Francis the same year produced more than 100. These events killed people and caused enormous damage in areas that were not considered to be in the storm's primary impact zone. The same physics apply to Western Pacific typhoons. The scale of the systems is larger, the moisture transport reaches further inland, and the populations affected, particularly in agricultural and industrial areas of central China that do not have tornado warning infrastructure comparable to the U.S. Midwest, are frequently caught without warning, without shelter options, and without the cultural familiarity with tornado behavior that allows people in high-risk areas to react quickly when the sky changes. Hubei province does not have tornado shelters. It does not have the dense network of Doppler radar systems that gives the U.S. National Weather Service the ability to issue tornado warnings with an average lead time of 13 minutes. What it has is a population that was watching typhoon tracking maps on their phones, assuming the worst was happening somewhere else, while the atmospheric conditions for a violent tornado outbreak were quietly assembling above their heads. Now let us talk about what comes next, because Typhoon Maysak is not the only storm in the Western Pacific right now. Super Typhoon Bavi has been the system attracting international attention this week because of its extreme wind speeds and its direct impact on United States territory in the northern Mariana Islands. Bavi is the bigger storm, the stronger storm, the one generating the most dramatic satellite imagery and the most alarming wind speed measurements. But Maysak has already demonstrated something that Bavi has not yet been given the opportunity to show. Wind is not always what kills in a tropical cyclone. Maysak stalled. Maysak saturated the ground. Maysak broke 5 dams in a single day in Guangxi and sent floodwater through villages that had no warning. And then Maysak's outer circulation moved inland and produced tornadoes in Hubei that ripped people out of their homes 12 stories above the ground.
思然，你看从手机上看过，看到一滩云，你看到吗？
吓人，我好害怕。
你看那一滩在转。
吹着风啊。
对，你看那一滩在转，看到吗？
小红。
What Bavi brings as it approaches the region will interact with a landscape that has already been profoundly altered by Maysak. The ground across Guangxi and Guangdong is saturated. Reservoirs that survived Maysak are operating at or beyond capacity. Rivers are running above warning thresholds. Drainage infrastructure is already overwhelmed. The soil that would normally absorb rainfall before it reaches rivers and reservoirs has no remaining capacity. Any rainfall from Bavi's outer bands, even if the storm weakens significantly before making landfall, will encounter a system with no buffer left. Flash flooding that would have been moderate under normal conditions could become catastrophic when the ground is already at saturation. And if Bavi's atmospheric structure creates the same conditions that Maysak's outer circulation created over Hubei, the same wind shear profile, the same moisture transport into the interior, then the tornado risk does not end with Maysak's passage. It resets. This is what a chain of storms looks like in practice. Not just successive impacts in the same location, but compounding effects where each storm degrades the resilience of the landscape and the infrastructure to withstand the next one. The dams that broke under Maysak's rainfall would not have broken under normal conditions. The tornadoes that formed in Hubei would not have formed without Maysak's moisture transport. The floods that are still spreading through Guangxi would not be as severe if the ground were not already saturated from a week of continuous rain. Bavi is the next variable in that chain, and it is arriving into a system that has already been pushed far beyond its normal operating limits. This situation is still developing. The rain from Maysak's residual circulation has not stopped. The damaged dams in Guangxi are still under stress. The tornado damage assessment in Hubei is still ongoing, and Bavi is still moving. Subscribe and hit the bell, because this is not one disaster, it is a sequence, and the next chapter has not been written yet.